Look at integration of trig functions now. So we're going to start with just the basic trig functions, then we're going to work up to trig products and trig sums. Okay. So to integrate the first one, cos 5x, what could we do? Yes, Dane.
Take it back to sine.
Yeah, so basically we've got to make sure we're looking at our tables. Remember, if differentiation's going that way, then integration's going that way. So if we're integrating cos, we're looking at cos, we're going to be going back to sine. Everyone happy with that, eh?
Yeah.
So that's cos x, going back to sine x. What have we got here?
Cos 5x.
So what are we going to do? We're going to let u equal 5x. Happy with that?
Yep.
And then so our du by dx is going to be equal to 5. So therefore a fifth du is equal to dx. Hopefully I've done that enough now that you can see where that comes from. I don't have to go through every single step. So now what we've got to try and do is say that there is going to be integrating cos u times a fifth du. Everyone happy with that? What do we do with that fifth?
Okay, front.
So the fifth goes up the front. And then what do we do with the du? Just goes closer. I'll match up those dots, make it look pretty. So therefore, cos u, what's that going to integrate to?
Sine u.
So our answer is going to be 1/5 sine u plus c, which is 1/5 sine of 5x. Happy with that? Plus the c, yep. One the first time, one the last. Happy with that? Now hopefully you can see, oh, well that's just like the exponential functions, and you can probably, hopefully you'll be able to go, that's going to go to the sine of 5x divided by the derivative of that chain part in by the time the exam comes around, but that's the long form of that. Happy with that?
Yeah.
And if you apply that to the next one, how do we do the next one?
And then u equal cos u.
So if we say u is 2x,
U by
take the
dx.
5 out the front, that's going to be sine of u. We're going to say du by dx is going to be equal to 2. So half du is equal to dx. So if I put the du there and I put the half there, hopefully you can see what I've done there. Sine, going back to my formula sheet. Sine, its negative sign goes to cos. So what does positive sign go to? Yeah, that's what I was just mentioning before. That's the tricky one. You just got to, well, not tricky, but with everything else going on with the assessments and the questions, the last thing you think about is the negatives and positives. So make sure you don't make that mistake. You happy with that? Yep. But again, some of you are going, I know what I'm doing here. I can probably go from there. I can probably go to 5 cos 2x over 2 being a negative plus c. Either of those are appropriate. Okay, just showing you the substitution for that later. Okay. Now there are some special cases, and the special cases is to do with cos x and sine, or cos squared x and sine squared x. Okay, but we'll try and get to those ones. I'll give you a bit of practice at the first ones, then we can go to the other ones. All right. So you've had a bit of time now to explore the first ones. Any major problems?
No.
The first one, I mean, you've got to make sure that, like sec 3x, tan 3x, for example, you just got to be able to look at your formula sheet here and go, oh, sec 3x, tan 3x. Oh, yeah, that's going to go to sec 3x. But you then divide it by the chain rule. Hopefully that makes sense.
They both roll like
Yeah, exactly the same rule. Yep. Tan x, sec x will be the same thing. But this one here, so the last question on that exercise that some of you guys were asking about was this one here. Okay. Now that one there, from your identities, tan squared x plus 1 equals sec squared x. So therefore, tan squared x minus 1 is tan squared x. Therefore, when you're integrating that, you're actually integrating that. Okay? And because sec squared x goes to tan x, negative 1, what's going to integrate to?
X.
Yeah, so it's going to go to tan x minus x plus c. Okay? But, so that's that tan squared one. But there are these special cases around sine squared and cos squared. Okay? And so, and this is going to lead on to tomorrow's lesson for us, but can you write sine, or how else can you write cos squared x?
Right place.
So you go
1 minus sine squared.
You can write that. You can write like 1 minus sine squared x, yep. But we're still running into the same issue of having a cos squared x. What we then do, we can't let u equal cos in that situation because it's not going to cancel with another part of it. So what are we going to do there? How else can you write cos x? Cos squared x. Yeah, cos x times cos x. Cos x times cos x. Okay. Now, there are other ways, and the book tells you a different way, but I think when I was going through this with another class, this is how they decided to do it, and it was much, much easier. So if you look at your formula sheet again, where are we looking at? Ultimately, what you could have used down here is these double angle formulas. You could have said, you could say here that cos squared A is equal to cos 2A plus 1 all over 2, and you can integrate that. That's like harder. But ultimately, where we're going tomorrow, if I come back up here, is these. And so some of you asked me, can you ever have sec 3x tan 2x? And the answer to that is you won't at level 3. But you might have a sine 2x and a cos 2x, or a cos 3x or something like that. So here what we've got is actually this one here, eh? So cos squared x is the same as cos x times cos x. So if we're looking at here, we're trying to convert that into that there. So what do you have to do? Yeah, what's A and B? X and x. Yep. So it's going to be cos 2x plus cos of x minus x, which is 0. Happy with that? Which is cos of 0 is 1. So we go back to our form. I'll go back to the question here. So that again, hopefully you guys remember that that was 2, wasn't it? So what do we need here?
1/2.
We need the half there. Okay. So that's now going to be the half. So we're going to be half integral of cos of 2x plus the cos of 0 with respect to x. Which hopefully you are happy with that being the cos of 0 is 1. So now we're integrating. Okay. Which is actually how I did it with the rearrange the double angle formula anyway. So now how do you integrate cos 2x?
Well, 1/2 sine.
Cos 2x goes to.
1/2 sine.
Does cos go to sine or does it go to negative sine?
Cos goes to sine.
Okay, so it's going to go sine 2x over 2 plus x.
Times
Happy with that? And then you go to plus c. So that's going to go to sine 2x over 4 plus x over 2 plus c. Why is my c not c over 2? Yeah, because it doesn't actually matter when you do it. It could be c over 2. It's just ultimately it's going to be a number. And the number's going to be 4. It doesn't matter if it's 8 over 2 or whatever. Does that make sense?
Yeah.
Can you see where we're going there? And so that one there is just the same thing. We turn that into sine x. We make it a 2.5 to make it. We can use that product to sum rule, and that's sine is sine. So that's that one there. So it's going to be cos of x minus x, which is 0, minus the cos of 2x. Okay, sorry, that should be 1, should it not? It's cos of 0, which is 1. Okay, which hopefully you can follow to your answer being x to the 2 minus hope that wasn't the answer there. Okay. Questions, problems with that? So tomorrow what we're going to look at is using those ones there